Good afternoon and welcome. Appreciate your attendance here today. We're doing the talk on sustainability and how we leverage what we've done with the OCP committee and group. I'd like to welcome everybody that's online and viewing. We're going to try to get through this in the allotted 15 minutes. If there's questions for us, you can meet us at our booth there and we can talk through some of the details on that. So here we go, we're going to get started. I like to show this because it's a younger younger picture of myself. Went with the beard during COVID, as many have. So in a nutshell, Fred Reber. I've been with Vertiv for 16 years and came from a liquid cooling business, so my background is thermal. But we're going to take you on a story that covers both thermal and power and how we move towards sustainability. So Vertiv is a supplier for the data center business. We do power, cooling, racks, number of products to help data centers run. And you can see numbers are showing here, pretty large company that can help you deploy. I think the key for this is we can help deploy and maintain things nationally and internationally, and also service equipment globally with the number of service folks we have around the world. So I'm going to take you on a journey here of sustainability, and we're really looking at a few different categories here. You know, every week a customer will come to us and ask us, what are your sustainability plans? How can I get to carbon-free or carbon neutral by 2030? And so here's just a few suggestions that can get you there with the help of some of the work we've already done in OCP. Now, one of the things that we talk about a lot are UPS efficiency or power system efficiency. And so you might see numbers quoted at 96% or 97%. For us, we're really focused on reducing those losses. So, you know, you can have a 1% increase in efficiency, but that could mean a 30% improvement in your losses. The other thing is zero carbon, right? We're always trying to get to zero carbon, and we're developing solutions in that area, both in the cooling and the thermal, that can help you achieve those goals. And then, of course, we're here in the Bay Area where we're experiencing a drought of epic proportions. So saving water is important here, but it's important everywhere, and it's certainly a big sustainability play. So using zero water is a big help towards getting sustainable. Also, zero waste. You know, I've been helping with customers design data centers for a long time, and you know, trying to get that data center to run at the design intent that it was originally designed for, meaning running at the utilization levels that we designed, and also running at the delta T's that were designed initially. Often that moves during the implementation process. So, you know, we're going to be focused on all these categories in the presentation. So if we build on what we've done with V1 and V3, if you had implemented a V1 or V2 rack, what you saw was a move in efficiency. Customers have told us, hey, I moved to a V1 system or V2 system, and my efficiency really improved. Well, it was not a coincidence, because what we've done is we went to a different architecture, you know, from 2N to an N+1 on the power side. So what that means is if you had a primary and a backup, now you were operating at 50% utilization. But if, let's say, you do a 7 to make 6 or a 5 to make 4 system on power side of the business, now your utilization has increased and you've shifted the curves of efficiency. So you've automatically increased your efficiencies, reduced your losses by moving to that new structure in V1, which is going from 2N to N+1 on the power side. The other thing we see in the V1 improvement is, so we were right around 10 kilowatts per rack in that design. Now in V3, we're implementing liquid cooling. So if you have a chance to come over to our booth, you'll see some liquid cooling rails that are on the back of a V3 rack, and you'll see how that's going to be implemented. But implementing liquid cooling can now take your capacity up and increase that. So from a standpoint of, you might have had 3 racks, and now you may be able to do the same capacity in a single rack. So using liquid cooling will get you there. The other big change in the V3 will be the move from 12 volts to 48 volts. So obviously with the higher voltage, you're going to get less losses. Again, focusing on less losses in the power distribution system. So if you add the combination of liquid cooling and the reduction in losses of the power system, you're going to see some nice improvements as you move towards a more dense solution with the V3 design. Now, what does that mean from a metric standpoint, and what are the things we focus on? So many of you who are in the data center business focus on PUE. So that's going to be the total energy consumed divided by the IT. And as you go through PUE and WE for water, and then ERE, you can see the elements of the equation and how that impacts us across direct-to-chip, immersion, and then some of the benefits that you'll see. So let's spend a little bit of time on this slide. So as you look at direct-to-chip, what you have is a content of about 70% of that heat from the processors going into the fluid loop. So that's a pretty big improvement. And as you all know, water is better transfer of heat than air. So with that, we're able to increase the density as we move to liquid, obviously, and really gives us a way to get the highest liquid temperatures. Now, there's a couple of things you can do with that. So if you're in a greenfield design and you're implementing this for the first time, you have the ability to make the decision to increase your water temperatures as you deliver them to the CDU, then onto the liquid-cooled rack. So that's one way, is you can elevate your temperatures there. The other thing is it gives you much better control of the new processors that are coming out that are going to require liquid cooling at the chip level. So that'll give you some options with a prepackaged V3 design. You can also look at immersion to accomplish this as well. So I recall I told you about the 70% that goes into the liquid on a cold plate design. Well, in immersion, you're going to have the rest of that covered in the full envelope of the server. So that gives you a nice heat capture to the fluid. The whole point, though, of this being that you want to increase energy efficiencies by moving to the liquid platforms. And with the new designs that are being done in V3 with the cold plates and the CDUs, you'll be able to get there. Additional benefits should be obvious: reduction of footprint. So if you're able to densify your racks, you reduce the number of racks, your carbon and your footprint's going to reduce itself as well. Now, let's talk about what this means in kind of general numbers. So I'm going to take you through some reduction numbers that we estimate for implementing this as you go. So as I mentioned, it's about the losses. So if you were to move from 95% to 96.5, doesn't seem like a big percentage increase, but really that equates to that 30% power loss. If you now have a lower DC current, like moving from 12 volts to 50 volts, that's down 75%. So you're combining the two, starting to build a really good sustainability story. Now, higher capacity racks with reducing the footprints, that's also a nice move in the right direction. Now you'll notice the next few bullet points, there's a few asterisks, and they're really recommendations that can be included in our V3s and future designs with OCP that will move this needle even further. So customers have asked us, they want to implement a V3 design, but they have requirements for multiple voltage sources coming in. Now those voltage sources can be from things like the need to come from a different source. Maybe they're using a hydrogen fuel cell, or they're doing standard generators. Maybe they're doing diesel generators. There's going to be multiple voltage requirements there. So I'm going to show you a chart in a few slides that'll kind of define what that means. Now, there's energy optimization that can be had as well. As we all know, there's peaks that happen within the course of the operation that may increase the usage of each server. And if architected correctly, we're going to offer a suggestion with the implementation of BBUs and battery technology that will also help the sustainability story. And then growing the BBU size, maybe going to a higher runtime BBU. And then the idea of peak shaving is one that we'll offer too as another alternative, where you would be able to use the battery backup and maybe cap the DC power shelf at a level that allows you to use both sources. That'll really help you. So keep in mind that those asterisk points are really ones that would be recommendations to build on the sustainability story. So, you know, there's two things I hear out there. I'm going carbon neutral, or I want to be carbon free. So don't get those two confused, because they're very different. Carbon neutral could mean, okay, I'm using a diesel generator and I'm generating carbon in one area, but I have a wind farm in Indiana. So I'm offsetting the two, right? Well, actually, I think the real goal is trying to capture that carbon and be carbon free. So let's go through this slide. So I'm going to move from the top left down and around up to the top right. In the first corner section, we talk about what we see mostly today, which is you have a main power system from utility, and then you have your backup power. And that's feeding the UPS storage systems to the server racks and the auxiliaries. Now, if you make the battery, or if you change from a diesel generator to a source that's a hydrogen fuel cell, whether it's PEM or SOFC, that's given you the opportunity to now reduce that carbon that was generated in that application. So that's a big step in the direction towards getting carbon free. But I'll also say that, you know, the hydrogen can be what I call either blue hydrogen or brown hydrogen, right? Depending on if you're capturing the carbon off the CO2 process or not. So that's one more step in getting you further down the carbon-free story. So let's go to the bottom left. And so now if we were to switch out the diesel generators and move over to hydrogen fuel cells, whether it's PEM or SFC, to supply the batteries, now you're in a position over in the bottom right where you can supply grid power or battery from the hydrogen source as a free carbon-free source, and then the utility backup can be the actual backup. Now, the benefit of this is if you're getting clean, sustainable power from your utility, now you've got that from both sources, right? You've got your hydrogen source from your battery backup, and now you've got a clean, sustainable source that's coming from the utility. So, and then as you move up, let's say that source that's feeding the batteries and getting those batteries charged up, and that circuit, now if that's coming from the renewables, that's basically nirvana for carbon-free design. So if you were to go to renewables as your source, and you're supplementing that with hydrogen, and then you're using your utility, that gives you multiple sources. So in the last conversation before this, I chatted with you about our requests from customers are about providing multiple batteries or multiple voltages, and how can you help me implement that? This is a way to do it. Now let's put it in numbers. Let's say on the left side, you're going to see the sources. So we have AC utility, battery energy storage, and then the hydrogen fuel cells. And that's going to have real benefit if you've got on-site fuel storage and production from the renewables. Now, that's going to feed into the voltage line that we have here from the hydrogen fuel cells. We've shown here 380 volts DC. And then from the AC utility, that's coming in at 480 3-wire, 240 volt 4-wire. So you've got multiple sources that are coming in, and now you have sources that could be both from a carbon-free generation. And then the last piece of that, you see the box in green. By the way, this model has been evolving even as recent as this week, as we engage with customers on implementing these types of designs. The blue or the green box is showing an alternative where you're powering that battery energy storage, and maybe with the possibility of also implementing peak storage in that. So now you've got some great ways to bring in carbon-free designs with using renewables, using sustainable sources from your energy company, and also using hydrogen fuel cells. So it's going to be a mix, a combination of these technologies engineered in a system like you see on the screen that will get you to a carbon-free design. So the other thing I wanted to mention too is if you look at the BBUs and the battery energy storage systems, as we move that to a longer period of time, that becomes a great source for the peak shaving that I mentioned earlier. So, and then obviously local generation using DC coupled hydrogen generators, really that becomes what, a continuous duty battery. So, you've seen hydrogen cells used as a proxy for primaries for some time and for generators, and this is kind of a slightly different application there. So that'll give you an opportunity to really go around and generate some carbon-free power design using the designs that we already have put into the OCP racks in V3. And so by combining the move from 12 volts to 48 volts, the ability to go to liquid cooling, you're attacking the sustainability issue from both the thermal side of it and the electrical side of it, and then combining that with the power delivery really completes the picture of getting to carbon free. So with that, I guess do we have enough time for a few questions, or? No, we're done. So I would say thank you. The slide deck, we can make that available to you if you'd like to see that, and if there's any questions, please stop by the booth and we'll be happy to answer any questions. Thank you.